Hello,
Hey,
Jayesh.
hi, Old. Hey, hi.
Hi, Jayesh. How are you doing?
I'm doing good. How are you?
I'm doing good. Hope you're enjoying the session of Murugan from the backstage.
Yes. It was really good.
Awesome.
So he has set
So,
standards so high, so now I have to kill it.
no. We know you will be really awesome, and our participants are really excited for the session. So, Jayesh, I have your screen already, so I'll just show it on the screen so that you can give a quick introduction about yourself, like what you're doing
Sure.
and what your session is going to be today.
Cool. Yes.
Yeah. So here you go. You are live.
Cool. Thanks for it. So good afternoon, everyone. Today, I will be talking about distributed tracing, which is getting a lot of mind share in last few years. Some people even go ahead and call it foundation of DevOps, new foundation of DevOps. So we will see if it really justifies its fancy new title or not. So I'm Jayesh Ahire. I'm currently working as a founding engineer at Traceable.ai, where we are building a modern AppSec platform based on distributed tracing and machine learning. We also have open sourced our underlying observability platform called Hypertrace. And apart from my day job, I also do some independent AI research around distributed neural computers, and I'm involved in this since past few years. So if you want to chat about my work, collaborate, or discuss on some projects, you can find me on Twitter at jayesh_ive1. Cool. So let's go through our agenda for next 20 to 25 minutes. We will see why observability became important and what is it. Then we will discuss around, in particular, about distributed tracing, and then we will see a demo of application instrumented with tracing itself. So let's jump into our first broader point for a day, observability. Uh, so monitoring or traditional APM solutions have been around from quite some time. And as this quote says, that monitoring tells you whether a system is working, but observability lets you ask why it isn't working at any particular point. And this why is very important. So I guess we should first discuss why do we need observability, and then talk about what is it. So there are so many reasons actually behind this, and let's just walk through a thought process which will help us understand the reasons better. So if you see, like most of the tech giants, including companies like Amazon, Netflix, started to build their systems using a monolithic architecture because back in the time it was much faster to set up a monolith and to get the business moving, and that was important. But over the time, as product matures, or as we say, fat growth happens with the growing systems, the code also gets more and more complicated. So they all face the same problem and looked at microservices as a solution. And one of the biggest benefit of using microservices is that each microservice can be deployed, scaled, and developed separately, and you can even replace and upgrade any part of the system independently. So everyone started adopting and using microservices, and here we are today, like looking at very complex modern microservice-based architectures. So uh, like what were the benefits there were for the older technologies? So some of them were like they were really limited set of well defined failure modes. Like yes, things broke earlier as well, but you would pretty much know what broke at any given point, or you would find it quickly, because a lot of older systems failed in pretty much same three older ways, and they will fail in those ways again and again, and you know that what's the problem behind the whole thing. But as our systems become more and more complex, the possible failure became more abundant, and we created monitoring tools to help us figure out what was going on in the guts of our software. So we kept track of our application performance and monitoring data collection and time series analytics and all those things. But this process was manageable for a while, and it got quickly out of hand because of, again, complex modern systems. So modern systems, when we talk about them, with everything turning into open source cloud native microservices which are running on a Kubernetes clusters, they are extraordinarily complex, and they are now being developed faster than ever, like between CI, CD, DevOps, agile development, progressive delivery. The software delivery train is also speeding up day by day. So, with this complex distributed systems which are being developed at the speed of light, the possible failure modes are also multiplied. So, when something fails, it's no longer obvious that what caused it. Like we cannot keep up with this by simply building better applications or doing some magic. So, But again, talking about this, nothing is perfect. Like everything will fail at some point. But the best thing we can do as developers is to make sure that we will know when the software will fail, and it should be easy for us to fix the issue. And when we talk about again this thing that unfortunately many modern developers don't know what their software failure modes are. Like in many cases, there are just too many of those, and sometimes we don't even know what we don't know. Like and then this is basically dangerous because unknowns means you won't put an effort into fixing something or fixing a problem in your system because you don't know that problem is existing in the first place. Again, like standard monitoring, the kind of that happens after the release cannot fix this problem. It can only track the known unknowns or track KPIs, but tracking KPIs is only as useful as the KPIs themselves. Like if they are relevant to the failure, they might be detecting, then they are relevant. Otherwise, they are not of any use. So reporting performance is the only as useful as that reportingly accurately represents the internal state of your system. So your monitoring is only as useful as your system is monitorable, right? So when we talk about this concept of monitorableness in your system, we call it observability. So let's just define observability in a broader way. Like in control theory, observability is defined as a measure of how well internal states of your system can be inferred from the knowledge of that system's external outputs. Simply putting, observability is how well you can understand your complex system just looking at the output. So metrics, events, logs, traces, or as we call them, melt, are at the core of the observability. But observability is more about like it's a whole lot about more than just the data. And uh, like just consider a process like placing an order on any shopping website or Amazon. It failed due to query timeout. So what characteristic did the queries that timed out at 500 milliseconds share in common? Service versions, browser plugins, or something other than that. So here, what helps us is instrumentation. Instrumentation produces data, and queuing that data answers our basic questions about our system. So telemetry or collection for data from instrumentation is a very important part when it comes to observability, as telemetry is what aids observability. So we have to keep some things in mind, like telemetry data isn't observability itself, and instrumentation code is how we get the telemetry. So to aid the observability use cases, your application needs to be instrumented, and telemetry data will describe your system's internal events. So it basically provides you a view into the same underlying truth as monitoring. So let's talk about okay. So let's talk about what I mean when I say metrics, logs, and traces, which will pave a path through to the tracing itself. So first, metrics. Metrics are basically aggregated summary statistics, and they are so valuable because everything from operating system to application generates metrics, and they will at least contain a name, a timestamp, and a field to represent some value. So there are so many resources come ready to help us about themselves. Metrics is an obvious first place to start debugging or start when it comes to monitoring. It's the first place to look at. So, and when we talk about logs, like logs are detailed debugging information emitted by processors. So, logs are perhaps the second most important tool in the monitoring toolbox because virtually everything logs information. And like they will log information about what they are doing at any given point. And what's more to that is log tends to give more in-depth information about resources than metrics. So if metrics showed the resources that log will tell us why it died in the first place. And our focus for today, and like last but not least in the monitoring triangle, is distributed tracing. So it provides us insights into full life cycle, or we call it like traces of a request to a system. Traces allow you to pinpoint failures and performance issues with so many applications interdependencies in your microservice world. So these operations will typically involve hops to the multiple services, and these hops are what we call spans. So traces then add like critical visibility into the end-to-end health of your application, and they are solely focused on the application layer and provide limited visibility into health of your underlying infrastructure, but they are still very helpful when it comes to playing at your application layer. So even if you collect traces, you still need metrics to get the full story of your environment. And APM tools feed trace information into a centralized metric store. So traces provide a nice source of data for app centric view. So talking about it, like structured data can be transmitted into any of these formats. So each of them have their own importance. And cool. So like now we know about observability, we know about metrics, logs, and traces. Let's just move to our topic for today. Like we are here for talking about distributed tracing. So let's just move to distributed tracing and talk about what is it. So as I said, like throughout the observability thing, that observability is about understanding how transaction flows to the network and the infrastructure. So in a monolithic app, like suppose a Java application, it is feasible to reason about the state and performance of the transactions. Like a client makes a web request and maybe it's passes to a load balancer, and it goes to your web application or like application server, and some database transaction happens in the backend where like you might query your record or anyway database record get updated and the response is generated and it gets back to client. So, like you will say that there are hops in the system, but this transaction generally takes place in a linear way. Like when you talk about monolith, it generally takes place in a linear way. Here you can see that client initiates a one request in the network, which goes to load balancer, and from where it goes to like a web application and then database, and then like finally that A3 responds back to client. So it's quite possible to instrument each of the hops and visualize the state of the transaction and its performance to the monolith. But it's different than talking about like complex modern architecture. So modern distributed systems, when we talk about them, they are made up of number of microservices, and they represent a complex entity. So a transaction might pass through one microservice or two microservices, uh, like databases, and they might come back and forth in different microservices. So there might be so many interactions happening around the microservices. So in this kind of scenario, the path is not very simple. The path is complex. Like here, a request gets initiated at A0, and like it goes to it might request some operation from service B, and then B might request some operation from service C, and then service C might request some operation from service A. So it's like it's complicated interaction between all the services. So it's quite possible to instrument each of the hops and visualize the state of the transaction, but like it's more complicated than monolith itself. Like so as I said, the transaction is quite different. We have assumed that our system is located in a single virtual entity here, but in when you talk about real world scenario, that your system might be distributed across the world. Like there might your one microservice might deployed in a Asia region, and one microservice might be deployed in the US region. So you have to consider latency among those as well. So as I said, when it comes to distributed tracing, it like distributed microservices and systems, it's quite complicated. So what is distributed tracing in the first place? So why distributed tracing we should use here, or why how it is helping us here? So tracing basically tracks actions or events inside our applications, recording their timings and collecting the other information around them, nature of the action or event. And to effectively use tracing, we need to instrument our application in the first place, which will generate the data or generate the traces for the actions we want to monitor. Like for instance, if we want to monitor interaction between microservices, we have to instrument our microservices, then it will generate a HTTP request, and uh, we can see that request passing through the all the microservices. We can see those hops and traces. The trace is an entity which wraps this request and records, and with the start and end time with other information or context, which we will talk about later. So, why do I care about all this? Like, why should you care about all this? So, tracing basically reduces time in triage by contextualizing errors and delays. It helps you visualize latency, like time my service took with versus how much time it was waiting for other services. It helps me understand the complex interactions, and it helps me see my architecture and visualize my architecture in a better way with a live dependency diagrams and a bunch of fancy stuff. So how okay, so like if I want to explain this in a very simple words, let's just assume you want to book an Uber. Like in a normal days, you will go from one place to another place. You will travel frequently, and when you go out, you want to book an Uber, and you just open your app. You requested for a ride, and it calls some discovery algorithm. Let's just assume that the discovery algorithm is the first hop in our interaction. So it calls some discovery algorithm. It showed you a bunch of cabs available around you, and then you choose a payment method which called like payment service. So this is your second hop. Then the third one will be like you got paired with some driver, which is like suppose there's a pairing service, so it's a third hop. Then when you are paired with your driver, you both are talking to each other, suppose, and that interaction is happening through calling API or Twilio API for that sort. So then that will be your fourth hop. So even if you consider very basic architecture, we are seeing four different hops, like a one single trace in a four hops in just calling a single write. But it's not that simple. Like there are millions of services behind the whole thing, and like tracing helps us to go through all those services and see which service broke at any given point. So, talking about trace, span, and context, like what is it actually? So, I will use this diagram. So, span is the primary component of a trace, and span represents individual unit of work done in the distributed systems. So, spans usually have start time and end time. And first span in the request is called as a root span, and all the subsequent spans we call them as the child spans. So a trace constitutes more than one span. Like in our example, we have assumed that A1, A2, A3, they're like B3, and there are multiple hops happening. So they all are spans in a particular trace, and the spans are linked to each other using a trace ID. So this makes it possible to build a view of the complete life cycle of a request as it propagates throughout the system. So again, like talking about distributed context, which is really important here and which is a really good thing to have. So they can have the spans can have user defined annotations in the form of tags, which allows you to like add metadata to the span to provide assistance in understanding where the trace is from. And you can also like attach logs as a key value pair in this, or metrics as a key value pair in this, and you can actually see your logs for the particular trace. So it is really helpful in that case as well. And you can use this trace data to visualize your system. You can use this trace data to visualize latency, your live application flow, which we will see in demo as well. Cool. So this is how the trace for the real world application looks like, and it is calling multiple services, and you can see the latency for the multiple services over here. Cool. So enough talk about the whole stuff. Let's just see everything in a live demo and see how actually tracing will be helpful in debugging your performance issues or your application failure, how it actually looks in a real world. So before just jumping to a demo, I will just talk a bit about Hypertrace, which we'll be using for demo as well. So Hypertrace is a real-time observability platform that helps teams make sense of their production request and trends in their network. So Hypertrace converts distributed trace data into relevant insights for everyone. Like infrastructure teams can identify which services are causing overload. The application teams can understand which requests put their service objectives at risk. Deployment teams can identify which version is causing problem in your system. So Hypertrace basically accepts all the major tracing data formats, which means that if you already have a distributed tracing enabled with Jaeger or Zipkin or OpenSense's Open Tracing API, you can go and try Hypertrace without changing anything. So we created it at Traceable and we open source it now. Community is helping us to build it as a best observability platform out there. So if you want to try out Hypertrace, you can just go to GitHub repo for Hypertrace. You can play around with the code. You can clone it. And if you want to deploy Hypertrace on any of the platform. So basically, there's hypertrace.properties file in the repo. You can change the ST environment variable to, maybe if you want to deploy in Azure, you can just change it to Azure and run this dot slash hypertrace.sh install file, and it will deploy the whole hypertrace platform on Azure. So you can set your kube context manually, or you can, if you don't, it will select your automatic kube context as well. So if you want to try it out locally, we also have Docker Compose file. You can just run that Docker Compose file and get Hypertrace running locally as well. Cool. So moving forward to our demo, like we will see the demo of online boutique app, which is created by Google Cloud, and it's a perfect application if you want to see tracing. Like this involves a lot of services like recommendation engine, product catalog service, then it has payment service, it has card service, and it has ad service. It has multiple services. So it's a real world example which you can use for demoing tracing and see the capability of tracing in real world. So we will just place bunch of orders, so it will generate traces, and it will send those traces to. This is using Jaeger. Basically, it will send those traces to Jaeger, and we will visualize those traces in a hypertrace. So moving forward, okay. So here we are on Hypertrace dashboard. It shows you like latency, calls per unit rate, top assets. You will see top endpoints, and you will see top services. You can adjust your time range as well. So suppose I adjust it to 1 hour, then you will see your can see like you can go through your top endpoints, which endpoints are being used most, and all that stuff. So application flow, as I said, you can use real time dependency graph for your system. This is how it looks like. Like front end service is talking to uh, bunch of other services, and you can actually see data about each of the service as well, like latency, call rate, error rate, and it identifies services and backends automatically, so you don't have to do anything. It will identify your services and backends automatically. So if you go to any of the service dashboard, this is all any service owner might need. And if you look at the dependency graph, your service is talking to all these endpoints, and you can see them in real time. You can see latency, and you can see all the details for each of the service and endpoint. You can see your top endpoints there, then radar, health radar, and you can see a bunch of metrics as well. So if you go to endpoints, uh, like these are all the endpoints front end is using. If you click on any of the endpoint, you will see similar dashboard for endpoints as well. You will see metrics for each of the endpoint, and traces for each of the endpoints. So if I click on any of the trace, you can actually see the trace view for that particular trace. And here I can see that the recommendation service is taking quite a lot of time. So maybe I will need to do some optimization over there. And you can actually go to that service and debug it, and uh, like
Sorry
make
to
it
bug
make
you, Jayesh.
okay.
Sorry to bug you, Jayesh.
Oh,
I think we
time.
are taking bit of time.
Cool, cool, cool. So I will just wrap it up.
Yeah,
So
yeah.
this was basically like a trace view. The Explorer thing basically gives you a lot of filters, and this helps you slice and dice in your traces. Like you have traces from bunch of different applications or protocols. You can just filter on your protocol and see HTTP traces only. So this helps you in you can slice and dice your spans as well. So there are a bunch of filters you can use. Custom time ranges there. So this is okay. So this was mostly all about Hypertrace, and yes. So if you want to use Hypertrace or try out Hypertrace, contribute to it. We are open for that. Like you can just go to this Hypertrace organization on a GitHub, and you can choose your favorite service, and you can start contributing to it. We even have Slack community where we talk to people who want to contribute, or we talk to people who want to try out Hypertrace. You can definitely join a Slack community, and we will like to interact with you guys as well. So if you want the slides, you can just scan this QR code and get Google's get the slides. And thanks. So yes, I'm done finally. If you have any questions, or if you want to talk about Hypertrace, you can ping me on Twitter at Jayesh_Ive1, or this is my email ID, jayesh.iv@traceable.ai. We will surely love to chat with you guys around the use cases you have over here. Oh, I'm just looking at the comments. Rohit, you can come now. I'm just looking at comments. Ashok is saying that